It feels like in the blink of an eye, ChatGPT went from this niche experiment to a global phenomenon that, let's be honest, has changed everything. But for all its power, how it actually works? Well, that's a total black box to most of us. So, let's pry it open.
Think about it. You've definitely used it, right? Maybe to write a tricky email, or explain something complicated, or just to come up with a silly joke. But have you ever stopped to wonder what is actually going on behind the screen when you hit enter? How does this thing turn your words into a coherent, sometimes brilliant answer? Well, that's exactly what we're going to dig into today.
All right, to get to the bottom of this, let's start with what its creator, OpenAI, actually says. Now look closely at the words they use here. Answer, admit, challenge, reject. I mean, these aren't words you'd use for a simple spell checker, right? This is about more than just predicting the next word in a sentence. It suggests some kind of judgment, and that is the real mystery. How on earth did they build that?
Okay, so to figure that out, we've got to break this down into a few pieces. First up, Section 1, the phenomenon. We need to get a handle on the absolute basics. What is this thing really?
Okay, so at its core, ChatGPT is what's called a large language model, or LLM for short. And you can just think of it as this incredibly sophisticated prediction engine. It's been fed a gigantic portion of the internet. We're talking books, articles, websites, you name it. And its main job, believe it or not, is shockingly simple. Just predict the most likely next word in a sentence.
But hold on a second. That just brings up a huge question, right? If it's just a fancy autocomplete on steroids, how does it follow these really complex instructions we give it? I mean, is predicting the next word really enough to create that helpful assistant that we all know?
Well, OpenAI's own research gives us a pretty clear answer. Nope, not even close. On its own, a raw LLM is powerful, but it's kind of dumb. When they took their base GPT-3 model and gave it a super simple task, explain the moon landing to a 6-year-old, it just completely failed. It didn't get the intent. It just saw a pattern of words and started spitting out similar questions. And this is the perfect illustration that raw computing power is not the same thing as being useful. So, if just predicting the next word isn't the whole story, what's the missing ingredient? Well, that brings us right to Section 2, the engine. To really get what's going on, we have to look at the T in GPT.
That T stands for transformer, and this piece of AI architecture, honestly, is the revolution that made all of this possible. This slide really breaks it down. See, older models, they read text sequentially, one word after another, just like you or I would read a book. But that's slow, and they'd often forget what the beginning of a long sentence said by the time they got to the end. Transformers, they do something completely different. They look at all the words at the exact same time.
So you're probably wondering, how does it do that without turning everything into a jumbled mess? And the answer is this brilliant idea called the attention mechanism. The best way to picture it is like the model has a magic highlighter. As it looks at the whole sentence at once, it can highlight and pay more attention to the specific words that are most important for understanding the meaning of any other word. It's how it builds this deep contextual map of the text, all at lightning speed. And this transformer architecture, it allowed for scale that is just mind-blowing. I mean, just look at this timeline. The key thing to watch here is parameters. You can think of them as the little knobs the AI turns to make connections. In less than 5 years, we went from GPT-1 with 117 million parameters to GPT-3 with a staggering 175 times billion. And then GPT-4 comes along and it can understand images too. This is that raw power we were talking about earlier.
Okay, so now we have this incredibly powerful, massive engine. But how do you take all that raw horsepower and, tame it? Turn it into something that's actually helpful and conversational? That brings us to Section 3, the polish. This, my friends, is where the real secret sauce comes in.
And this is really the core challenge of AI alignment. Think about it. A model that's trained on the internet is going to reflect, well, the internet. All of it. The good, the bad, the ugly, the just plain weird. So the question becomes, how do you steer it towards being helpful and safe and away from just making stuff up or saying harmful things? The answer is this amazing technique called reinforcement learning from human feedback, or RLHF. It sounds complicated, but let's just walk through the 3 steps here on the slide. First, step 1, supervise. You have actual humans write out perfect, high-quality answers. This gives the model a gold standard to learn from. Then, step 2, reward. The AI generates a few different answers, and all the humans have to do is rank them from best to worst. This ranking data trains a separate AI, a reward model, that basically learns what humans like to see. And finally, step 3, reinforce. The main model spits out an answer, the reward model scores it, and that score acts like a little treat, a reward, that nudges the main model in the right direction. Do that millions and millions of times, and you're essentially baking human preference and judgment right into the machine.
All right, so we've got the raw power of the engine and the human feedback that gives it that final polish. That brings us to our next section, Section 4, the impact. The big question now is, so what? Does all this training actually work? And what are the real-world consequences?
And the data on this slide, well, it speaks for itself. This isn't just a cool theory, it really, really works. These charts are comparing the basic GPT model with one that's been trained using that human feedback loop. Just look at the results. The scores for things like toxicity and hallucinations, which is just a fancy word for making things up, they totally plummet. And at the same time, the scores for truthfulness and being appropriate, they shoot way up. This is the proof, right here, that this human feedback process is incredibly powerful. And the potential here is just huge. We're talking about a method that can actively fight against harmful content, that can align these powerful systems more closely with what we actually value. It could even help reduce the biases that sneak in from all that raw internet data. It might even lead to smaller, more efficient models, which would make this tech available to a lot more people.
And this is a big but, it's not a silver bullet. This is absolutely a double-edged sword. These models can still pick up and even amplify the societal biases that are all over their training data. They can still hallucinate and create very convincing lies. And we, as a society, are just starting to wrestle with the big effects. Everything from the deskilling of certain professions to the scary potential for this to be used to create disinformation on a terrifying scale.
So let's step back from all the technical nitty-gritty for a second and get to our final section, the big picture. Now that we have a sense of how this machine works, what does it all mean for us? Because this technology is forcing us to ask some really profound questions about our own future.
The philosopher Hannah Arendt wrote this quote decades before anyone was even thinking about AI. But wow, has it ever been more relevant? A people that no longer can believe anything cannot make up its mind, and with such a people, you can then do what you please. I mean, when we have technology that can generate believable lies in an instant, the very idea of a shared reality starts to crack. And figuring out how to manage that, that's one of the biggest challenges of our time.
And that quote really leads us to the final takeaway here. ChatGPT, and AI like it, isn't some alien intelligence that landed on Earth. It's a mirror. It was trained on the collective words of humanity, our knowledge, our creativity, our biases, our biggest flaws. It reflects it all right back at us. The technology is here. It's not going away. So the really important question isn't a technical one anymore. It's a human one. When we look into that mirror, what do we want to see? What should we be asking it to show us?